Today we will be discussing significant figures, otherwise known as sig figs, or shorthand writing it down if you're too lazy to write sig fig SF. Significant figures are literally just important numbers. Significant means important. Figures in this point or in this presentation is going to mean numbers. So it literally means just important numbers. In science, we measure things all the time, but we don't always have the exact same materials across all scientists or across all experiments. And since we don't have the exact same materials, we have to let each other know how precise our particular set of laboratory equipment is. And we're able to do that utilizing significant figures. We want to make sure that everybody knows exactly how sure we are about our answer so that we don't end up lying to them and saying that we are way more confident than we actually should be. So here's some examples of how different lab equipment can give us different levels of certainty. So here I have a scale reading at 5.0. That 0 got smudged a little bit. I'm going to fix it. 5.0 grams. Okay? But if I took that same cube and I weighed it on a more precise scale, I end up seeing that the mass isn't actually 5.0. It's 4.987. But since this scale could only guess that first decimal point, it wasn't able to see all of these numbers behind it. And so when we report our answers, we need to make sure we tell everybody that is looking at our stuff whether we are kind of certain or really certain about the mass. So we're going to go ahead and count sig figs. Sig figs, again, are just going to be how certain we are. The more sig figs we have, the more certain we are that our number is correct. First rule of counting sig figs. All non-zeros in our number are significant. So when I look at the number 847, I have 3 non-zeros, therefore all of them are significant, and I have 3 significant figures in that number. Zeros between non-zeros are significant. So here I have a 0 sandwiched in between 2 non-zeros. That 0 gets to be significant because it's in between non-zeros. So 802 will also have 3 significant figures. Trailing zeros. This is where we start getting a little bit weird. Trailing zeros are only going to be significant if there is a visible decimal point. So 100, no decimal point. Those 2 zeros are placeholders only, and they do not signify that I am certain about these places. So I only have 1 significant figure since I only have 1 non-zero. 123.0, however, since I have that decimal, that tells me that this 0 is actually a number I am certain of, so I get to count all of the numbers as significant. So 123.0 will have 4 significant figures. Last rule, leading zeros are never significant. They are not significant because they are placeholders only. So my only 2 numbers that I am certain of are the 2 and the 3. So in the 0.023, I only actually have 2 significant figures, even though I go out to 3 decimals. Leading zeros are for placeholding only. I do not feel confident about that. Now that we know how to count with sig figs, we need to know how to actually apply them, because you're not just going to be given a number and asked, oh, how many sig figs are in this particular thing? No, you're going to have to apply sig figs once we've actually done a problem or done some math. So that means we need to learn our sig fig math rules. Sig fig math makes math a lot easier, in my opinion, because I never have to read through the directions or guess exactly where my teacher wants me to round. Sig fig math will tell me exactly where to round every single time in every single circumstance. For multiplication or division, the number with the least amount of significant figures determines how many significant figures I get to keep in my final answer. So our example here, we have 18 times 23.7. When I multiplied that out, that gave me 426.6. Then I'm going to look at my number of sig figs. 18, those are both non-zeros, so they both count as significant figures. So I have 2 sig figs here. 23.7, all non-zeros, all are significant. I have 3 sig figs here. Since I have this as my least number of sig figs, 2 is the number of sig figs that I actually get to keep. Now this is where some people get confused. What we're going to do is we're going to start from the left and we're going to identify how many sig figs we get to keep. I got to keep 2, so I went to the first sig fig, second sig fig. This is the last number that I care about, this 2. I just have to look over at its neighbor to see if I need to round up. 6 makes me round up, so that 2 will turn into a 3. A lot of people mess up here and they just write the numbers that are significant. So they would write 43. This is incorrect because you're losing a lot of value with your number. Zeros can be placeholders, and that's what we have to do to preserve its value. So 426.6 is approximately 430. And that final answer, just to check, has 2 sig figs because this 0 is a trailing 0 and it does not have a decimal point, so it is not significant. So this is the correct number of sig figs for my answer. The next example I have is going to be that of division. So I have 407 divided by 8. When I did that, I got approximately 50.875. And then I'm going to look at my sig figs to determine how many I actually get. 407, I have a 0 sandwiched in between non-zeros, which means all 3 of these numbers are significant. So this is a 3 sig fig number. 8, obviously there's only one number there, so there can only be one significant figure. And since 1 sig fig is my least number of sig figs, I'm going to round my answer to 1 sig fig. So I only get 1, I start at the left. That 5 is the last number that I care about. I just look over to see if I need to round the 5 up. 0 does not make me round the 5 up, so I maintain it to maintain value. 50.875 is approximately 50. And so my answer that I would be reporting would be 50. That's multiplication and division. Next we have addition and subtraction. So addition and subtraction works a little bit differently. Instead of looking at the actual number of significant figures I have, I'm going to be looking at the number of decimal places that I am certain of. So my first example here, I have 6.43 and I am subtracting 2.1. When I did that, I got the number 4.33. I'm going to count my number of decimal places, not sig figs, for addition and subtraction. So this first number, I have 2 numbers after the decimal, so I will have 2 decimal places. And this number, the 2.1, I have 1 number after the decimal place, so I will have 1 decimal place. Since 1 is less than 2, I am only going to be preserving 1 decimal place. So I come over, and instead of counting sig figs, I'm just going to go to the 1 decimal place I get to keep, the one that's furthest to the left. I see that's a 3. So that 3 is the last number I care about. I'm going to look over to see if I need to round up. Its neighbor is also a 3, and 3s do not make me round up, which means that my final boxed answer would be 4.3 since I was able to maintain a single decimal point.